Software Engineering Radio, Episode 5, Model-Driven Software Development. Hey everybody, thanks for listening to this new episode of Software Engineering Radio. Before we actually get started with model-driven software development, I want to mention a couple of other things. First of all, we want to encourage you to give us feedback. We need to know what you think about the topics we talk about the level of detail. Should we provide more overview or more specific details? Which topics do you want to hear about in future episodes, and who do you think we should talk about? Who should we interview? So you can help us make this a good program by giving us feedback what you want to hear. Also, I want to refer you to two other podcasts. First of all, Frank Westphal has released a new episode in his Tonabnehmer podcast series. This is a German podcast, so it might not be interesting for all of you. But after, I think, 5 months of waiting, his newest episode, released, I think, on Monday this week, has Thomas Baustott and Ralf Wirdemann talk about their experience and also their new book about Ruby on Rails. Another podcast you should listen to if you're in the Java world is the Java Posse at javaposse.com. That is javaposse.com. They provide weekly episodes that give you the latest updates on news in the Java community. They also have, from time to time, interviews with celebrities in the Java world. For example, they had Jonathan Schwartz, the CEO of Sun, on their show. I think having Software Engineering Radio on the one hand side that gives you the fundamentals of software engineering, and also having a newscast on your specific platform on the other side is a really great combination. So if you know about newscasts for other platforms such as Microsoft.net or Ruby, then let us know so we can point everybody else to those podcasts. So after this rather lengthy introduction, let's now get started with the topic of this episode, which is brought to you by Markus and Eberhard. Note that we had to cut this discussion into 2 parts because otherwise it would have been too long. So the next episode of the Software Engineering Radio podcast will feature part 2 of this discussion.
So in this episode we are going to talk about model-driven software development and how it makes life easier for software developers. So my initial question is, which are the basic concepts and how do they fit together?
So the basic idea of model-driven software development is to make the development efforts more domain-specific. So if you develop in the banking field, then you might want to use banking-specific abstractions when building your software. And if you work in the radio astronomy field, for example, then you might want to use abstractions that are specific to that domain. So instead of requiring developers to manually or mentally do the transition from domain concepts down to the software technology concepts all the time when they're programming, the idea is to provide them with more domain-specific abstractions and let tools, transformers, generators, do the transformation down to the software artifacts, such as, Java code or EJB or something like that. So, and in order to do that, you need a number of things that aren't usually used in like traditional software development. One is obviously the model. A model resides in the center of all this model-driven development universe. That's why it's called model-driven development. And models in that sense are formal models. So formal means that tools can actually work with them. Tools know how to process models. So those models have to have clearly defined meaning, which means they have to have a defined structure. You have to express them in a well-defined way. And also the semantics is important to define. So in order to come up with these formal models, we need a modeling language that has those concepts inherently built in. And usually general purpose modeling languages like UML are not formal enough. So if you have a UML diagram, it's quite hard to know specifically what it means. in order to generate artifacts from it. So what you usually do is you come up with a DSL, domain-specific language, or others call it domain-specific modeling language. That means you analyze your domain and you come up with the core concepts of that domain, and you model their relationships and their properties and their semantics in the most extreme case. Usually semantics aren't modeled formally, they're just described. But what you do is you build a meta model, and the meta model defines the constructs that developers can use for modeling. So to make that a bit more concrete, if you look at the UML as an example for a modeling language, people can use concepts such as class, association, attribute, operation to build their own models. Yeah, like you have a class person with the attribute name and first name. In order to formally define what a class is, you need to have a meta model, and that meta model contains exactly those elements that you'll use for modeling later in the next stage, basically. So things like class, association, generalization, attribute, operation are elements of the meta model, and that means that people who build instances of the meta model, define instances of those meta model concepts. So if I build a model based on UML, I can create an instance of the meta model concept class and assign its name to be person. And then I instantiate an object of type attribute, which I call name, and which has the type such and such, string usually. And then I can create a relationship between the class and the attribute, a relationship that could be called like owns, and that means that the class owns the attribute name. So that's the basic idea. Another thing you need to come up with when building your domain-specific language is the concrete syntax. So the meta model defines the concepts you use in the language. They're abstract. It doesn't say how those concepts are represented. The meta model doesn't say that UML classes are rectangles with these several compartments. The concrete syntax does that. So if you build a domain-specific language, you have to define the meta model as well as the concrete syntax, and that concrete syntax can be graphical or textual. That's important to really note. In all this MDA discussion, we'll catch up with that later. People always think in graphical models, and that's certainly one option, but it's not the only one. Once you have the model built on your DSL, you have to make sure that the model is actually used in some way. We don't want to put the model in a shelf and look at it just for documentation purposes, because that would be, the old style, and nobody does that voluntarily. So the idea is to transform those models into something that's executable. And to do that, you need to have something called model transformation. That is basically a technique to transform one model into another. There can be several steps, like you can transform one model into another model, and you can transform that model into yet another model. And once you did that, you can finally transform that last model in the chain into code. Of course, you can also generate, in one step directly from your model into the executable code. It's basically a question of modularization, whether you want to have one step or several step transformations. So the final step of all that transformation stuff is almost always code generation.
Okay, so to sum up, basically as a developer you build models that are domain specific. So for example, that contain contracts and whatever you have in your domain, and this is expressed in the domain specific language. So technically speaking, the domain-specific language defines what you can do in your model, and the representation can be either textual or graphically. It's not limited in any way. And at the end of the day, the semantics or the real meaning of these models are expressed in a generator. The question is how this all can be used in a project environment and what the benefits are. So can you give an example about a concrete implementation of such model-driven software development in a project context?
In one project, the idea was to use model-driven development to simplify working with a potentially complex architecture. Now, I'm going to elaborate later on the difference between what we call architectural or architecture-centric model-driven development and non-architecture-centric. But the idea was this architecture was built from things like components, long-running business processes, interfaces, contracts between those components. We had to manage things like versioning, so we had to know that if we replace a component with a new version of that component, we had to make sure that the system still worked, and not at runtime, but we had to know this statically. So we had to do things like dependency analysis. Also, we had to deploy the business logic, onto several different execution platforms. Like one of them was Spring, another one was the Eclipse framework. So what we did was we came up with a meta model that captured the core architectural abstractions. In that case, these were things like components, interfaces, operations, the component instances, their relationships, the process definitions, and all these kinds of things, so technical aspects. So, and what developers then did was they used a UML tool in that case to come up with the models. So they used class diagrams with stereotypes to define what components are and their interfaces and the relationships between the components. Actually, what they used was a UML profile that was built on top of our domain-specific meta model. And then we use code generation to come up with the concrete implementation. So people would draw their component structure in the UML diagram, generate base classes from that. Actually, it was a Java project, so they generated Java code. And then they inherited from that generated base class, and into that inherited class, they added the business logic. So we didn't try to express the business logic with this domain-specific or architecture-centric MDSD approach. What we did was that we modeled the business processes with UML. So we used UML state charts to come up with the business processes, and then we generated from those UML diagrams the artifacts that would be used by the process engine to execute the process. We did two things. First we used the JBPM process engine, so we generated the XML input files, and later we generated native implementations of those state machines because we thought that was simpler overall. So that was one example of a project.
So what you're saying is there are basic concepts like components or business processes or whatever that were used as a basis for code generation. And what I'm wondering now is this is not domain specific in any way, because it's not something that is specific to the domain that we tackled in this project. It's rather something that shows up in every project more or less, because every project has some kind of components and there are some kind of business processes that you're trying to model. So and it's not specific to, say, insurance or banking. Is this really model-driven software development? Is this really a domain-specific language, or what is it?
There are various flavors of model-driven development. One is what we call architecture-centric model-driven development. So the domain for which we build domain-specific languages, models, and all that stuff is the architecture of our system. So the meta model contains those rather technical concepts such as component, interface, contract, whatever. And the idea is to make working with this architecture simpler, to generate glue code automatically, to make sure that the programming, the business logic, containers, components are not, you don't have all those angled brackets everywhere from all the XML and all those invasive programming models from the various platforms. So the idea is to make programming with a technical platform easier. And also, by formalizing your project architecture into a meta model, this actually helps you come up with a well-defined architecture, because you have to think about your architecture thoroughly and clearly define what your things in the PowerPoint presentation actually mean. And by doing that, by trying to come up with such a formalized architectural meta model, your architecture is refined. It actually gets better by doing that. We sometimes say that model-driven development used in that way acts as a kind of architectural catalyst, because it helps you come up with a better architecture. And that in this specific project, this was very obvious. The people at our customer had more or less a big problem to really get started. They did various specific elaborations, but they weren't able to come up with a blueprint for the system. And doing this model-driven stuff really helped there. So this is the architecture-centric model-driven development. Of course, you can also try to abstract really domain-specific concepts. Now, domain not being the technical aspects of your system, but rather things like insurance contracts, validity constraints for all kinds of functional or non-technical things in your system. You can do that. However, what I always recommend is that you should start with the architecture-centric thing, because if you want to abstract business concepts, then you have to really understand your business concepts very well. And usually as a technical person who tries to learn, all those model-driven tools and all that new stuff, it's good if you do this based on a domain that you know relatively well. And that's, at least I hope, that is the architecture. So by starting with architecture-centric model development, you kind of get rid of the problem of understanding deeply a domain you don't yet know. Rather, you start with your architecture as being the domain. And then, once you did that, you can cascade additional layers of DSLs on top of that. I mean, that's probably something that's maybe too advanced for this introductory podcast on that topic, but the idea is to use model transformations to, for example, model things like a component that verifies business contracts or insurance contracts, and then you generate these basic artifacts from that. But again, that's something we should discuss maybe in a subsequent episode.
So what you're saying is that one specific domain that you can use in model-driven software development is the architecture of a computing system, and this is one of the things that you could express very well with a DSL. And at the same time, this has the benefit that the architecture becomes a real artifact in the software. So you can actually say, okay, so this is the semantics of our architecture.
To iterate this point again, usually architecture is something people talk about, or draw some PowerPoints and that stuff. Architecture is not an artifact you can use, you can verify. And if you do this in a model-driven way, the architecture is formalized and it's tool usable, because if you build your concrete models of your application, something that some people call the design, an instance of the architectural concepts, then you can use model validations and all other cool things to verify that the model is actually consistent with the architecture. So architecture becomes executable.
And also you can add new features to the architecture in a well-defined way. So what I'm wondering is, what do you think, where is the biggest benefit in this field? I mean, is it just the first step towards an architecture-centric model-driven software development, or is the real benefit that I should aim for to have a real domain-specific language for the real domain that I'm trying to model in the real world?
Of course, the holy grail, so to speak, is the real domain, like insurance or automotive engine control systems. However, considering today's complexity in software development, which is, tests, more or less awful platforms, you have to write a lot of glue code, you have to do all these things to get your business logic running. So if you automate those technical aspects of your project, that's already a big benefit. Actually, I think many organizations never go beyond this architecture-centric model-driven development, and that's fine. If you have various different domains which you all run on a standard infrastructure with a standard architecture like J2E stuff, then it's quite feasible to come up with a standardized architecture-centric meta model, and on top of that you add additional business logic and different kinds of business logic for which you don't want to provide domain-specific languages. So it's perfectly okay to start with architecture-centric MDSD and never go beyond it.
If you aim just at the architectural level, the next question would be, do you think that this should be standardized? Should there be one way of doing, say, Java, EE, architecture, and standardize a domain-specific language for this, and then reuse it in all projects? Because, I mean, obviously this would mean that you can reuse your implementation and everything gets much cheaper and easier and so on.
What you're saying is that if you come up with the meta model and the generators again in each project, then you always have the effort of building these things over and over again, and that makes it more expensive than it maybe needed to be. So, I mean, so it sounds like a good idea to, download this cartridge for Hibernate and Spring, and then you just draw the pictures and everything is fine. And maybe that's not really a bad thing. However, what you lose is if you just download the cartridge and don't think about your own architecture, then you lose exactly that benefit, which is that building a generator helps you understand what your architecture is all about. Once a while ago, I was trying to build a generator that would generate an editor based on Eclipse GEF for domain-specific meta models. So this was actually one meta level higher, but that's not important here. So the problem was I had to understand GEF, and GEF is really not simple, and I really had a really hard time doing that, and I tried to understand GEF before starting to build a generator for it, and I gave up on that. I just started building a generator because as soon as I understood something about GEF, I coded that knowledge into my generator. So building a generator helps you understand the thing for which you build the generator. So, and if you just download cartridge X for technology Y, then you lose that benefit. On the other side, being a consultant, I have that problem all the time. I have to reinvent the wheels in many, many projects, and writing your fifth generator for the fifth Hibernate mapping is obviously a boring thing. So there are really fundamental technologies for which pre-built cartridges or generator components are a good thing. So what I recommend in that space is that you should use those off-the-shelf cartridges, but they should be hidden from the actual modeling. So what you should do is you should build your own meta model for your architecture. You should express your architecture in that meta model using DSLs based on that meta model, and then use model-to-model transformations to generate the input for the off-the-shelf cartridges that you might be able to download from somewhere.
So the GEF example makes me wonder, is this again fixing a bad platform using a generator? Because that's what we did with Xdocklet and EGB. So do you think that we could improve the infrastructure, like, for example, the graphical editing framework or whatever, and come up with an infrastructure that is so good that we don't need to have MDSD anymore, and we don't have to have any generators and so on, because everything works out quite fine?
Yes, certainly. I mean, the platforms today are far from what we would like them to be. I mean, many people bash about J2E, although J2E is not that bad, but you have to write a lot of stuff to get your things running. So writing better platforms will certainly reduce the need for generating stuff, especially for those, dump generators that, just generated dump glue code. So, for example, if you look at Spring as a framework that you could use as a base for your applications, then the need to generate stuff is certainly reduced. So yeah, to some extent, we need MDSD because our platforms are bad. However, as soon as you get really domain specific, so if your meta model doesn't do the architectural stuff anymore, then there's this discussion is kind of not relevant anymore, because, good platforms don't help you with your domain specific things. So if we stay in the architecture-centric MDSD space, even then, it usually makes a lot of sense to use generation on top of good platforms, because if you do the models right, you can generate all kinds of things, starting from ARN files over files that package your applications, test cases to some extent at least. You can generate all kinds of artifacts that are outside the scope of your execution platform. Another thing is that if you do component-based design and you have a model that expresses components and their interfaces, a second model that expresses component instances and their wirings, and a third model that expresses how those component instances are deployed on system nodes, like processes and hosts, machines, then you can generate all kinds of things from that. For example, you can generate all the code or all the configuration that is needed to make remote communication between components located on two different processes possible. And even in Spring, this is something to do. I mean, you have to write this configuration file, you have to provide all kinds of things. It's not as bad as in J2E, but having the well-separated, spectrally separated models that give you a good overview and consistently generating the artifacts that you need is certainly important. So one last comment on that. Even if you use something like Spring, you still have to come up with non-runtime things, such as, for example, Hibernate mappings. And nobody automates that for you. So you have to generate those. So nobody would probably argue that Hibernate is a bad platform. It's probably a quite good one for persistence. At least I don't know of a better one. But you still need to generate those mapping files. So there is something to do usually.
Okay, so we've been discussing MDSD so far. And what I'm wondering, of course, is how is this different from MDA? Because this is obviously the big standard by the OMG that also standardizes UML and Corba, and everybody thought this was the next big thing, and now you're telling me that MDSD is actually the thing and the way to go. So what's the difference here?
I think MDA is a specific flavor of model-driven development. So what I'm saying is, MDSD defines, things like what's a model, what's a meta model, what is a DSL, how do those things go together, how do you generate stuff, what's the difference between architecture-centric and the non-architecture-centric thing, how do you organize your development process so that this approach actually works. So these kinds of things. MDA is a standardization initiative by the OMG that tries to standardize some aspects of that whole thing in order to, become tool interoperable and all those other advantages of standards if they're worked out well. So specifically that means that, for example, the OMG standardizes a meta model. So that would be the meta model for building meta models. So anyway, it's important for building tools that can exchange MDSD artifacts. And this is called the MOF, the Meta Object Facility. So, or other things like, for example, for model-to-model transformations, the OMG has just recently more or less finalized the QVT specification, a standard for query views and transformations. They're also working on a standardization of model-to-text. So, their approach is not really different. It's just that they narrow down the general approach to certain standards. And that could be important. Although, realistically speaking, the MDA standard in the past hasn't been very practically useful. So the MDA standards paper itself is basically a vision statement. And the first rather concrete result of all those standardization efforts is QVT. And also for QVT, people don't necessarily agree that what they standardize is actually the right thing. MDA is certainly useful to standardize certain aspects to make tool interoperability become a reality, but the general thing is not something that the OMG trademarked. Maybe one thing, OMG has always had a focus on interoperability between runtime systems, that would be Corba, and between tools. And so again, in MDA, the focus was to become interoperable between platforms. So the idea is to model your business logic in PIMs, platform-independent models, and then transform that basically into, using various intermediate steps, PSMs and stuff, to generate that into executable code that can run on various platforms. So the cynics will say that, unfortunately, not everybody kind of standardized on OMG's platforms, so now the OMG is moving one level up and standardizes the model layer so that everybody can use their own platforms, but still people use OMG standard development approaches. One last thing, in practice, using MDA tooling today means that all your DSLs are basically UML profiles. That's not something that's kind of written into the standard. You can use all kinds of DSLs based on MOF, and the UML is also based on MOF. But in practice, if you want to do MDA with official MDA tools, then that means you have to render all your DSLs as UML profiles. And that's something you might like or not like. Some aspects of your systems cannot reasonably be modeled in UML, and restricting yourself to UML-based DSLs is not a good thing in general.
And as we pointed out, there are also textual DSLs, and that's just something that you can't do with UML. So it's not really useful to limit yourself there. So then if MDA and the MDA tools are not the thing that you should generally use, then the next question obviously would be which tools should I use and which other options are there that I can have a look at. So can you give an overview about those?
So the idea of using domain-specific languages to make development more efficient and automating the transformation into executable code is not specific to MDA and MDSD. There are various industry initiatives that look at that. Historically, generative programming, you might know the black book with the white cat on it from Christoph Czarnecki and Ulrich Eisenecker. Generative programming basically aims at the same thing. You have specifications and you transform them into optimized products. So, same idea. Also, if you look at domain-specific visual modeling, that's something that has been used for a while. There's a company called MetaCase from Finland. They have a tool called MetaEdit, and they've been using this approach for a long time. So it's not new. It has become a hype topic because of OMG's MDA. So that's something that has to be said positively about MDA. It has brought this approach into kind of everybody's mind. Other folks, like for example Microsoft, are also working on it. They call their approach software factories. Software factories are not just about using DSLs. It's generally about domain-specific product line engineering things, and there are other aspects to that than just DSLs, but DSLs are an important part. And then there are things like, for example, the language-oriented programming thing from the IntelliJ folks. Is that their name? No, JetBrains. JetBrains is the company name. They're building a tool of the meta programming system. So this is kind of everybody's hobby at this time. Now, if you want to start today, you have to be a bit pragmatic and you have to select your tools. Of course, you can use UML tools as one way of building DSLs, and then you have to use some kind of transformer or generator framework that is, after you wrote the UML model to an XML file, you can then read that XML file and generate code. So that's a standard approach. And there are various tools. There is, obviously, I have to say, open architecture where I'm committer in this project. There is AndroMDA. There is various commercial tools that do that. By the way, you shouldn't use XSLT transformations or JSP engines. That doesn't scale. But then if you look a bit further and you want to do sophisticated model-to-model transformations or build your own graphical editors, you should definitely have a look at the Eclipse world. On Eclipse, there is the GMT project, stands for Generative Model Transformer, and that's a kind of container project for all kinds of other projects. There's the model-to-model transformation engine, ATL. There is open architecture, where is actually a part of that project now. And there are other projects that aim at managing big models. And then there is also a very interesting thing which is called EMF, which is the Eclipse Modeling Framework, which is actually also a meta-meta model, one that is a subset of OMG's MOF. We won't go into details here. Anyway, it's much simpler than the MOF, and most of those Eclipse-based MDSD tools actually built on top of EMF. For those who are interested, Open Architecture 4 also uses EMF. A very, very interesting upcoming project is the GMF project, and that's a project that allows you to generate graphical modeling editors from a meta model expressed in Eclipse EMF. So you build your domain meta model in EMF, add a couple of configuration models, not going to go into details here, and then you press a button, and what you get is an Eclipse plugin that contains a graphical editor, graphical in the sense of boxes and rectangles and these kinds of things, to build instances of your domain-specific meta model. And that's really cool, because if I look at projects today, the problem is not that I need functional, highly sophisticated transformation languages, such as QBT. What I need is small, tailored, specific editors to express my models. And that's where GMF is going to be a big, big win. This concludes this first part of the discussion of MDSD. In the next episode, we'll talk about some less technical issues, such as the relationship of MDSD and agility, MDSD and offshoring, as well as how to introduce MDSD into your projects. Thanks for listening, and hope you're back next time. This was another episode of Software Engineering Radio. For general information, feedback and past episodes, go to se-radio.net. Software Engineering Radio wants to thank Henning Pauli for providing the music we use on this show.